Hello guys, welcome back. In this video, let us learn about MSK, that is hands-on with MSK. In this session, I'm gonna tell you how to host or how to run our application on MSK. So first we need to store our application and then we'll process our application as well. So that whole thing you're gonna learn from this video. So for that, now I'm searching for MSK. You can see I got this. Now I'm opening this MSK. I hope you watched the theory regarding this MSK. I have already provided. Those who haven't had any idea about MSK theory, please go through MSK theory that I have already provided. Now I'm just creating one cluster. In this MSK, in order to run our application, we will run inside our MSK clusters only. Either storing or running, both will be done inside our MSK clusters only. So for that, I'm just expecting to create one cluster. So now I'm just clicking on create cluster. We can see, you can see we need to provide some details like cluster method. You want to start, that is a quick create or custom create. If you want to specify much more details, then you click on custom create. If you don't want to specify much more details and you want to provide only necessary details with a minimal details configuration, then choose this quick create. Here you need to provide your cluster name, whatever the MSK cluster name you want to provide in order to identify your cluster among multiple clusters. Then cluster type you need to provide. You want serverless or provision. If you choose this provision, then you have ability to choose your Apache Kafka version as well. And for storage, you can even choose this Zookeeper as well. And what are the broker instance types? So on which instance type your broker need to run. So based on your virtual CPU's requirement and storage requirement and network bandwidth, you can have multiple options here to select for this broker type. So currently I'm moving on with a default one, or else you can choose any one. Then you also have ability to select the storage. If you select this provision mode, if you select a serverless mode, then it will take care of storage. It will provide you a cluster storage of unlimited, and it also take care of cluster throughput, that is write throughput as well as read throughput. Everything will be taken care by AWS. We don't have editable configurations. We only able to edit the tags. If we choose this serverless mode, if we choose this provision mode, then we have an option to select the specific Kafka version, and we also have ability to select the storage and computing type. So that also we can able to select by using broker type. Here you can see we have multiple editable options. Yes. So just click on create cluster so that your cluster will be created. If you choose serverless, then select that and click on create cluster, then your cluster will be created. If you want to specify each and every detail, then you choose this cluster custom create, then you need to provide your cluster name. If you want to provide lab cluster as the name, then provide the lab cluster as your name. Then you need to select the cluster type. You want provisioned one, or you want if you select a provision one, then yeah, it will ask you some more details regarding your Apache Kafka version and how much storage you want. So you can see that was available here. And then it also asks you about broker instance type and number of zones you want to deploy your cluster brokers, and broker per zone, how many brokers you want. So that's also it will ask. Let's say, let us see serverless mode. In this custom create only, let us see serverless mode. Here you don't need to provide much more details regarding your cluster or storage. So that's it. If you choose provision mode, then you have much control about your storage as well as your cluster details, like broker details, number of brokers you want and in which region you want. You can see, so in first session we configured the cluster details and storage details. In second step we configuring the network, like in which VPC we want to put our cluster and in which zone you want to put your cluster. Based on your specific requirement, you can able to put your cluster in specific zones, in specific subnets as well. You have that control as well, and you can provide your own security group if you want. Currently I'm clicking on next. After providing that, then you have ability to select the IAM roles as well for authentication, then metrics and tags. So in order to monitor, you can enable the metrics and you can even provide the tags to identify these clusters among multiple. Then at last you can review and then click on create cluster so that your cluster will be created. So currently for this lab I have already created one cluster. Now I'm expecting to move on for that, so that I'm just canceling this cluster creation. You can see my cluster is in creating state. So after cluster creation also, we have an option to edit the cluster. So let's see what are the details that this cluster will provide me, or else this cluster will run on which Apache version. You can see that is available here, and total number of brokers that we created. Under properties we have much more details, like Apache cluster version and configuration. We choose a default one, and networking settings and broker. Per zone we are expecting to put only one broker, and totally 3 brokers we are using, and broker type is this. You can see the storage that we used, how much storage that we provided for this cluster to store my application data. We currently provided 5 GB, so that's enough for me. You can see multiple options, like security options also available. You can able to edit it after your cluster is created, and you have metrics option also, monitoring metrics. You can able to edit that as well. You can able to monitor the metrics under CloudWatch or open metrics with Prometheus. You can see log delivery. So currently it is not enabled. If you want, you can enable that by editing option and deliver to CloudWatch logs or S3 bucket or data firehouse as well. So these are the details properties regarding your cluster. Under metrics, you got the matrices regarding your cluster running, and cluster operations you can see here, and cluster alerts, tags, and integration. You can integrate this cluster with pipelines or other AWS services. You can directly integrate with a Lambda or step function. So if you integrate with step function, then this provides you ability to integrate with so many AWS services, or else API gateway. You can integrate with this cluster. You can integrate this cluster with event bridge API as well, and you can send your events to target services as well. So by using these services, you can able to enrich the data which is present in MSK as well. So by using this event bridge, you can able to filter the data, and you can able to enrich the data and transform the data by using these services, and you can store the data in specific target where you want by using these integration pipelines. And S3 delivery, it's a new feature. You can even deliver. So currently, now let's see our cluster is created or not. Status is creating. Now I'm moving back to cluster. So in order to edit all these options, we need to create one cluster configuration. Now I'm creating one cluster configuration with the name as lab config, and currently I'm not providing any description. So that's it. I'm just clicking on create cluster, create. You can see our configuration is just now created. Yeah, our configuration is created. So now we have created our cluster as well as cluster configurations as well. So let's wait for some time so that our cluster will be created. After creating our cluster, we'll connect it to EC2 instance, and then we connect it to this cluster to host our, to put our application in it and to get some data and to put some data in it and to run that application as well. So that's what our aim of this video today. Actually, what we done in this video is we create two topics in our cluster to store our application data, and we directly import our Python code to our cluster by using check IP address. I'll show you that as well in this lab. So remember, this storing and topics creation as well as your application running whole, everything will be done programmatically in this MSK. Now this cluster is in creating state. So in order to store my application, or in order to check the cluster details, like what broker instances I have and what topics I have in those broker instances. Now let's first we need to connect to EC2 instance. By using that EC2 instance only, we're gonna connect to this MSK cluster, right? So for that, I'm searching for EC2. You can see EC2 visible here. Now I'm going to EC2 dashboard, like instances I'm going. Now we just entered into EC2 dashboard. You can see I have already created one EC2 instance to connect to that in order to process my application inside this MSK. So we have an option that is connect. I've already selected this EC2 instance. Now I'm clicking on connect option. So now you can see we have an option to connect to this EC2 instance. That is at a downside, we can see an option to connect. Now I'm just clicking on it. It was opening a new web interface. So there it was establishing a connection. It's loading. Yeah, we connected successfully to our EC2 instance. Now I'm just clearing this page. Yeah, I cleared this page. So now I successfully connected to my EC2 instance. Now what I'm expecting to do is I want to use my MSK through this EC2 instance. So before using that, we must see the status of it. That is, it is active or not. You can see the currently the status is active. So from now we can able to connect to that MSK from here, and we can able to use that to create our application, to process our application as well, and to store the data in it. And where we store our data in topics, right? Yes. So we can also create our topics from here as well. Let's say I want to see what are my Kafka clusters that I have created from here. So for that we have a command that is AWS Kafka. Spelling is, you need to check with spellings, and list clusters. So that's it. By using this command, you can get your clusters details. So what are the clusters are there in your AWS account? So you can see I have some cluster info. Inside that I have my broker information, broker node, group information. So here I have in which subnets do my brokers are present, and what is the broker instance type, in which security group my broker, that is this cluster is present, and what is the size. This is all regarding your broker instance details. And this is your storage that we use, that you can be able to use for your cluster. So you can see 5 GB that is specifying. And you can see you're having a cluster ARN as well. We will store this cluster ARN in order to use our cluster, and even we can see our broker names. What are the broker names we have? So what are the broker servers which are running in my cluster? Those we can able to see by using this cluster ARN. So that we will see, and by using this cluster ARN only, we will create some topics inside our broker servers which are running inside our cluster. So in this, you can also see some encryption information is there, monitoring information is there, and we also have state, that is our cluster is in active state or in running state. That is creating state or in active state. Previously it was in creating state, now after some time it comes to active state. You can see number of brokers as well. 3 broker nodes are created for us. So let's say I want to see the status. I don't want this much of whole information. I just want to see my cluster status. So how I can get that? So by using cluster info list. So in that I have an option that is state. So by using that I can able to get that. So let's see how to query this whole data. So in order to query this whole data, we need to write the command, same command that we written previously, and with that we need to write query, and inside our cluster info list only, right, our state is present. So I provided that, and this 0 indicates the first value in my list. Basically this cluster info is a list of JSON scripts. So in order to pick the first cluster info, I need to specify that by using 0. Inside that dot state indicates that particular 0th cluster state. Now I am just clicking on enter. You can see the cluster state is active, right? Yeah, in this way you can able to check the status of particular cluster node. Now, since I'm expecting to store some topics inside my cluster and some application inside my cluster, I want this first cluster ARN. So where is this cluster ARN? Inside my cluster info list under the first item. So under this also my cluster ARN is here. So this is same like a state. How do we specify it? AWS Kafka list clusters. Query is my cluster info list dot. So in place of state, what I need to write? I need to write this cluster ARN, right? Yes. So then I got this cluster ARN. In order to store this in a variable, I need to assign it to some variable. You can see I have assigned it to some variable like cluster ARN is the variable that I am creating, where that stores the value that is provided by using this output. And I'm also expecting the output in the form of text. So that's why I return output as text. So this dollar represents this whole data value. So what this whole data value will provide me? This will provide me this cluster ARN. Where is that? Yeah, here it is. So this Kafka cluster ARN it will provide. And now I'm just storing it in one variable, that is cluster ARN, so that I can able to use it after some time. So I just entered, I just clicked on enter so that it will be run, and inside this variable my cluster ARN is stored. You can even check the data inside our variable by using echo. You can assume this echo command like print command to print your output, which is output. To print the value which is stored in this variable, we are using again dollar. Now I'm just clicking enter. You can see our cluster ARN is stored, right? Yes. So our cluster ARN is stored in this variable. Now I'm expecting to see what are the instances which are running inside this cluster. What do we call those instances? Running instances. We call them as broker instances, right? Yes. So I want to see all the broker instances which are running inside this cluster. For that, we have a command. You can see that is AWS Kafka get bootstrap brokers inside this cluster name, inside this cluster. So how we are specifying? By using cluster ARN to specifying that data. So I'm expecting brokers which are present inside my cluster ARN. To see that, I have written this command. You can see those broker instances will be written here. So you can see broker string and broker strings. Yeah, those all written here. So these are my brokers which are present in my cluster. This is one broker up till comma, and second broker you can see from here till here I have another broker instance, and from here till end. So where is it? So here I have another broker. So I have totally 3 brokers. Now I'm expecting to store some topics inside our brokers. So for that, so in order to store some topics inside our brokers, first we need to store this. So every time entering this value is not good. So I'm just expecting to store this inside our any one of the variable, and then by using that variable, I'm expecting to store under instances only, right? We store our data. So what is our data, in where I am storing? In topics only, right? We will store our data. Yes. So what I'm expecting is inside these broker servers, I'm expecting to store my data. So for that, so first I'm expecting to store this in one variable, and by using that variable, I'm expecting to see the topics in it, and I'm expecting to create some topics and then fill that topics with data. So first let us store this variable, that is, now I'm expecting to store these in a variable. You can see I have written a command for it. This export command is used to store, that is export whatever the string, broker string that we created to use. Now this whole command is nothing but what are the previous command that we written. So up to cluster, you can see AWS bootstrap brokers cluster. So that's we specified, and by using query command, I'm getting this particular data output. So I'm getting this output and I'm storing that inside my broker string. I'm just clicking on enter, so that our data is stored in the broker string. You can even see the data which is stored under broker string by using echo command. You can see what are the broker servers that I have running inside my cluster. Those all will be saved in this broker string variable, right? Yeah. Now I'm expecting to see the topics which are present in this broker string, that is inside my servers. I'm expecting to see what are the topics which are present already. So for that, I have written a command Kafka topics.sh. I want to list those topics from these bootstrap servers where my servers are present in this variable. So I'm just clicking on enter. So currently I'm getting command not found. So in order to use Kafka related commands, we first need to install Kafka in our system. So let's list and see. You can see currently I'm not having anything ls-la. So this will list your data in expanded format. You can see the hidden folders also by using this command. I have these all in my current folder. Now I'm expecting to install Kafka as well in current folder. To install Kafka command, I'm using this web request. So by using this URL, I'm installing the zip file from this location. So I'm just clicking on enter. You can see my Kafka is installed, right? Yes. So now I want to list what are the files in my current folder. You can see I have this file present in my current folder. I want to rename that file, that to Kafka folder. So before that, I would like to unzip this. So currently it is in zip format. I'd like to unzip that. So for that, I used this tar hyphen xjdf. So what are the unzip file that I have written this. So now I'm expecting to rename this to Kafka. So for that, so in order to move or rename this whole folder name to Kafka, you can use mv command. This mv command will move the data present in this to this Kafka folder. So you can list and see you have this Kafka folder now. So let us see what is the data what are the folders or data which is present in our Kafka. So now you can see we have bin folder is there, configuration folder is there, libraries folder is there, license and notice files are there, and site documents folder is there. You can notice here your folders will color like this, whereas your files will color like white, whereas your zip files will color like this, right? Yeah. So now let us execute the previous command to see, to list the yeah, to list the topics which are present in my Kafka. We have successfully installed our Kafka toolkit inside our server. Now I am expecting to list. Still, I'm getting the error, that is command not found. Till now, we just install the Kafka, but we haven't specified that path. So in order to recognize the path of my Kafka, we need to specify that. You can see we have bin folder, right? So that path we need to export. So I have written already for that. So I'm exporting path, that is the path home underscore EC2 user is the current path. Inside this I have Kafka folder. Inside this I have bin folder. So you can export that path. So now our Kafka path will be exported. Now let us see it will show me the topics or not. I am now listing the topics. You can see the topics are listed. You haven't got this error. So in this way, if you want any library or any software to install, you first need to install. In order to use directly from here, you need to export the path, then you can able to use that. So currently I have installed Kafka toolkit. Now I am using Kafka toolkit commands. So you can see this Kafka topics.sh is a command in our toolkit, Kafka toolkit. Now I am using that. So this list command is used to list the Kafka topics which are present in your bootstrap servers, where this bootstrap string will hold your all your bootstrap servers names. So in our bootstrap servers, so where our bootstrap servers are present inside my MSK cluster. So we have seen previously, we have seen what is our MSK cluster, and inside my cluster what are the servers I have, bootstrap broker servers I have, and inside the broker servers to store my data, what are the topics I have, those also we have seen just now. Now what I'm expecting is, I'm expecting to create two more topics. One topic is raw data and another topic is aggregated data. So for the raw data, I want to create one topic and store my raw data inside that. And for my aggregated data, so whatever the combined or aggregated data, in order to store that inside my Kafka, that is managed streams of Kafka, MSK, I want to create one more topic for that. So I'm just expecting to create two topics. So for that, I'm writing a command to create one topic, that is a raw data. So to create this topic, I have written the same thing that we written previously, that is Kafka topics.sh, and I have included create command to create this topic. At where I'm creating inside this bootstrap server. So I mentioned that. And in partitions, how many partitions I am expecting to store is one. But in real time, you may store in multiple partitions to get parallelism to execute your topic or to execute your query result. And this replication factor is currently I'm putting to. So now I just clicked on enter. Yeah, it's executed. Now let us see what are the topics that I have. You can see our raw data topic is created. Inside this raw data topic, we can now able to store our raw data, generate and store our raw data. Now I'm also expecting to I'm expecting to create one more topic to store my aggregated data or combined data. For that, I'm writing one more command. So it is same like this, but in place of topic name, I have changed my topic name as aggregated data. You can see it was running. Yeah, so it's created, assuming. Now let's list and check whether it's created or not. You can see I have two topics, that is raw data and aggregated data, and whatever the previous two topics are there, those are present. So we successfully created two topics to store our raw data and to store our aggregated data. We created two topics successfully in my cluster in my servers. Now what I'm expecting is I want to put some data in my raw data as well as aggregated data topics that are created inside my MSK cluster inside my servers. Now in order to put some data or populate some data inside these two topics, I'm expecting to run some random application and put some topics in it. I'm also expecting to run that or process that application inside this MSK only. So for that, so in order to, we first need to create some file, right? Yes. So to create the file inside my MSK, now you can note the point, we are creating our application inside our MSK only. So to create that, first we need to get the IP address, current IP address to connect to our MSK. So I'm just pasting this curl https check IP address dot aws dot amazon aws.com. That is, by using this command, you can able to get the current IP address https check IP amazon aws.com. I'm just clicking on enter. You can see we got some IP address. By using this IP address, we can able to connect to our cluster. So I'm just copying this. You can say an option copy. Yeah, I just copied this. Now I'm expecting to connect. You can say I have an option, that is Google Chrome. By using this Google Chrome, I'm expecting to connect to my IP address. So I'm just opening this Google Chrome and I'll paste my command there. I just pasted that IP address. Three thousand here is the port number. Now I'm just expecting to connect. So I'm just clicking on enter here. You can see it was loading. Seems to be, yeah, it's connected to some IDE, that is under home, under project, some IDE is connected here by using that IP address. Now what I'm expecting is, I'm expecting to see the files. You can see AWS folder is there, SSH folder is there, whatever the Kafka toolkit that we installed, that also showing here. So we successfully connected to our Kafka. Now what I'm expecting is, I'm expecting to create one Python file, and by using that Python file, I'm just expecting to populate, or I'm just expecting to get the data from that Python file, and I'm expecting to store that data inside my two topics. Since I am generating code for data, for raw data as well as aggregation data, I am providing my script or application name as windowed aggregated.py. So now I'm just clicking on OK. You can see one more file is created. You can verify this directly from EC2 instance direct connect, whether that file is created here or not by using ls command. I'm just writing ls. You can see that file is created here. So we successfully connected and we created one more file. Now in this Python file, I'm expecting to write my code. First, we need to write the import statements. You can see I have imported, but this fast library is not present directly. So for that, we must need to install that fast library from here, from this EC2 console, or else you can directly use here option, that is a terminal. By using this terminal option, you can open your terminal directly from here, and then from from here you can able to install your required libraries as well. So currently I'm expecting to install that fast library. So I'm using this command to install this fast library from EC2 Linux console. So I'm just clicked on enter. You can see it was downloading. So this library also getting downloaded successfully. Yeah. So now we can able to use that from here. So now I'm just clicking on save. We just imported the required libraries from till now. I'm expecting to create two classes for data to store under my topics. You can see I have created two classes, one for raw model and one for aggregated model, where this raw model will contain, this raw model class object will contain date as well as value, where this date is of date and time type. This value will hold the float value. Similarly, here in aggregated model, what are the objects that I create for this aggregated model class? So that will hold date variable, where that can contain, that can able to hold date time related data, and count variable will hold integer type value. Mean variable can able to hold float type value. So I created two classes. Now what I'm expecting is I am expecting to create one app to clean up the data, to clean up this raw data and store that data inside this aggregated data. So that's what I'm expecting to do. To do that, I'm expecting to create one app. You can see I'm writing code here. Yeah. So I've written. So this app, so I'm defining my app by using this fast module, so that we previously imported, and we defining our app by window dot aggregation, and our broker is Kafka is our broker, and we provided some more details like version and topic partitioning. By using this partition key, I'll define these partitions, and you can also see I have also defined few more options, that is app configuration interval, that is a cleanup interval I have defined by using this cleanup interval variable, and I defined my source as well as sink. So what is my source? This raw model is my source, and this aggregated model is my sink, that is the destination. And I have also provided the topic and sink. In place of topic, I need to provide my raw data topic name, and in place of sink, I need to provide my aggregated data name. So in order to define these variables like broker name, and partition keys, and cleanup interval, raw model, that is a topic as well as sink. Now I'm defining that. Now I am writing the values for those variables. You can see I have written the topic name as raw data and sink as aggregated data. This is the table where this tumbling table in order to perform our action. And so we can even specified the cleanup interval, that is 1, and window, that is 1, and partition keys, that is 1, and broker string that we're going to use in next. Broker string, that is nothing but, so we have created some broker string variable where we have stored our broker in server's names, right? Yes. So in order to store that, I have created one more variable, that is broker string. In my raw model, I have date and value. So from this value and date, I need to get some count as well as mean, right? So for this window processing, I need to define one more function. You can see I'm defining it by using this function, that is a window processor. So by using this function, I'm providing, so if I provide key and event, so by using that, I'm getting the timestamp values, and I'm creating the count and mean, and finally I'm printing that value as well. Then I'm sending that to sink. So what is our sink here? That is aggregated data, that is aggregated model sink, where the sink is nothing but topic of, so which topic? Aggregated data topic. So whatever the raw data we're taking and processing, that data we are moving it into sink, right? Yeah. So for that, I've also provided window processor function as well. In between, I need a table, right, to store all these manipulated values. For that, I've created a tumbler table, so that I am defining tumbler table here. You can see I've defined my app table by using the table, and list is the default value. Partitions I am storing, and on window closing, that is a window processor. So this window processor will process the data and close the window that I am defined in my tumbler table. And we are also defining the tumbling action and relative to field, that is on what field we are processing the tumbling action, that also we defined. So this tumbler table will actually call this what on window class, on window close class. Then your processing will be happened and your data will be stored under your destination aggregated topic. Now to print the windowed stream events, I have defining the app agent. So this will execute this function, and it will take all the events which are present in your stream, asynchronous stream, and it will list the values which are present in your tumbler table events, and it will append that inside our value list. And inside our table tumbler events, we again storing that values list. So now this is what our whole code is. In order to run our main function, we also need to define the main here at last. So that's I'm defining here. So app timer I provided, and producer to produce the data and put the data, send the data to source. And I also started my app main. This will start this and produce the data and put the data, sends the data to source with some random value, and a date will be generated by using this code, and that will be sent to our raw model, that is source. So what is our source? That is a raw model topic that we defined as our source. You can see this is our raw model topic that we defined. So if you run this, then your raw model will be populated, that is your raw model data will be filled. Now I'm saving this whole code by pressing Ctrl S, or else you can just click on file. You have an option that is save. You just click there so that your file is saved successfully. Now before running this, so if you run this, then your data will be populated to raw data. And before running this, I'm also expecting to provide this tumbler table. So in order to store this tumbler table in one of the topic, I'm expecting to create one topic in my cluster. So that's why I'm writing one code here. So to create one more topic, so based on our current need, we need one more topic, that is Windows aggregation tumbler table change logs. So to store that, we are creating one more topic. You can see under partition 1 and replication factor is 2, same as previously. We just creating one more topic. So now our new topic is also created. If you want, you can able to see that topics by using this list command, Kafka topics.sh -list, and bootstrap servers that we provided. So you can see one more topic is created. So now you can run your application that you created just now. So you can see list and see what are the applications you have created this application, right? Yes. So you can run that application from now so that your data will be populated to your source. So what is your source? That is raw data. By using what we are running this Python code is, or application code is, by using workers. So I'm just pasting one code, that is by using this Python 3 on this, we are actually running this. On top of these worker only we are running. I'm just clicking on enter so that our Python code is run. You can see starting. So our Python code is running successfully, and it was processing our window and generating events and mean, and timestamp is this. So like that it was running now successfully. So in this way you can able to create your topic, and you can able to you can able to create your application inside your MSK cluster, and also you can able to populate your topic with the data by running your application directly from your MSK cluster in this way. I hope you understood this, how to create your application and how to run that application to populate some data inside your topics. You have seen how to create your topics as well in this video. And if you want, you can able to, you are also seeing how to create a topics in between as well programmatically. You can see this means processing window is called, and whatever the raw data present in your raw topics, that will be processed and cleaned, and that will be sent to where your sink. What is that? Aggregated data topics, right? So your processor window is also running now. Now multiple process windows are run. So I can assume that my topic is populated. My topics are populated. Either it may be raw data or aggregated data. My topics are populated. If you want to see that, you can able to stop this process by clicking on Control C. Now I'm just clicking on Control C. You can see it was stopped. Now what I'm expecting is, I'm expecting to see the data, which is, so top 10 messages which are present in my raw data that I'm expecting to see. So for that, you have an option that is Kafka console consumer.sh. By using that, you can specify your server, that is a bootstrap server, and then you need to specify your topic. Then you need to print the messages from beginning till max, how many messages that you want, that you can specify, and just click on enter so that it will print the data which is present inside your topics, where those topics present in your servers, MSK servers. You can see top 10 data got printed. So I have date, I have value, and I have FAST. That is a Windows aggregation model that is run on that model. Let's say I want to see the data which is present in aggregated model. So you just need to provide your aggregated model topic name here, so that you can see the data which is present in aggregated model as well as from here. Now I'm just replaced that topic name. That's it. And the remaining command I haven't changed. That is same as previously. Now I'm just clicking on enter. Now you can see it is running. Yeah, top 10 messages, top 10 processed messages. You can see the date, count, mean. So those values you can see here. So that means our destination sink also populated with some data, and our source topic also populated with some data. So from this, we have seen our application is running and it produced some data into our topics as well. Now I'm expecting to store the output directly as a file here inside this, and I want to see the result. So for that, you need to import one more library, that is a JSON library, because I am expecting to store in the form of JSON. So I'm just clicked on import to store my output in one file. So I need to write the code for that as well. After my source and sink creation, so where are my, yeah. So after these source and sink creations, I need to define that code. Yeah, here I have defined the get aggregated method. So whenever app task, this task is started, this get aggregation function is started, and this opens the output file name in append mode, a plus mode, where that file is present in home EC2 instance only, that is at output.json. Here you can see such output.json is not available here till now. Now if I run this, then this will be created and this will open in the form of append mode, and each value in the stream will be taken and we are putting that in the form of object inside our file, whatever the whatever the output file that we taken, that is output.json. Inside that file we are writing that data by using json.dump. This json.dump will convert that object output object into this JSON format, and we are just putting it slash and presents. Each object will put on new line and this flush will clear the file after that. So this is the code for putting that. Now in order to create this file, I'm just saving this file by clicking Ctrl S, or else you can see this file save option. Now I'm just running this again. So by using this command, output need to be put in the form of text format. Now I just clicked on enter. You can see, let's verify. Do I got that output.txt? Yes. So now you can open that data and you can see that output is created successfully in it, right? Yes. So output, outputting aggregated event. So that's also seen here. In this way, we can even able to store our data directly in our file, that is in the form of JSON file or in the form of text file directly in our MSK. Even we can able to analyze that output as well. Not only topics, we have also seen how to put our data into output files, that is inside files. We can even observe the output of our script directly from this Linux terminal by using this tail follow option. You can see this is the output. You just click Ctrl C to stop printing these outputs. You can also see the JSON format of data by using this tail option. You just click on Ctrl C so that it will be stopped. Let's say you are expecting to analyze the aggregated data points in the form of chart or plots. So for that, I have written a Python script, that is a while, not Python script, it's a shell script only. While true, I am getting the output.json top 20 records and tailing that and printing that every time by sleeping 10 minutes, 10 seconds. And again, I'm running it and again, I'm writing it infinitely. You can see now the graph will get, you can see, yes, I just clicked on enter. You can see the graph you got like this. So in this way, we can even analyze this data visually by using this graph. So I hope you understood how to analyze this data as well. So in this way, you can even visualize your data as well by using this MSK. The data present in your topics, that also you can able to visualize in MSK in this way. So from this lab, the outcomes that you got are, you have seen how to create your MSK cluster, and you have also seen the how to connect to that MSK cluster by using the EC2 instance, and how to download the Kafka toolkit, and how to create topics inside your cluster, and how to see the topics, how to see the bootstrap servers, and how to create your application code, and how to run that application code, populate your data inside your topics, and how to visualize your data directly from Linux console. That's also you have seen programmatically from here. So I hope you have also seen the application running as well from here. So I hope you understood all the details about this MSK practical implementation labs and hands-on. I hope you understood this video and you got the content, knowledge, new knowledge or knowledge recap from this video regarding MSK. I hope this video is contentful. If you feel this video is contentful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys. Thanks for watching again.